Thank you, everybody, for joining our RV.NUG meetup today. Appreciate having all of you guys here with us today. We continue to have our online meetups, and we are planning on introducing or coming back to physical presence meetings next year. So what we're planning on doing is a hybrid model where we will have one meeting that's going to be physical presence every quarter, and then the rest of them will still remain online, which will make us easier to reach from other parts of the country or the world, and bring you guys some wonderful speakers. And just like today, we have a wonderful presentation for you guys by Tyler Thompson, a hands-on test-driven development. Tyler has been working as self-employed full-stack software engineer for the past 21 years, working with clients to understand their pain points. He proposes, then implements solutions from concepts through final delivery. He loves discovering how things work and is excited to share what he has learned with those around him. Check him out at www.designlogicsolutions.com. Thank you very much, Tyler, for joining our group today. Take it away.
Thank you. All right. Great to be here. Thank you for having me. Let me share my screen. All right. So yes, everything you just said is perfect. And so I've been a self-employed full stack developer for the last 21 years, and I love C#, I love .NET, and all the things that we get to do and solve problems. And that's obviously what we are problem solvers. And part of what we're doing today is test-driven development, how that fits into kind of what we do on a daily basis, and why I do it on my projects. And so this is the approach I wanted to take with this, is that because I was thinking through when I was trying to teach this to other people, I was thinking, what excites me is having my own project, going out, finding a client, whether there's a freelance job or whatever it might be, finding that project and then doing that project well and getting paid for it. And so, so I thought this would be a fun approach to kind of package this up in a fictional world for this. And so, here's the situation: is that you just landed a freelance project with Vend International. They're makers of vending machines. And you say, okay, well, this project would be great, and you've heard about test-driven development before, but you haven't taken the time to stop and learn it or experiment with it because you're worried about deadlines and it's going to slow you down or not, that kind of thing. And so this is an opportunity for you to experiment with this. And then you've asked me to walk along with you on this code and be able to say, hey, this is what I would do if this was my project and using test-driven development. And so that would be the opportunity for us to do that together. And so then let me paste this in our chat. But here's the URL to the Vend International requirements that they provided us. So this is Vend International, and it says, congratulations, after interviewing a number of software engineers, you have been chosen to develop 3 modules, which will be used in our Vend 2000 gum dispensers. And these are the 3 modules: a coin identifier, coin storage, and a gum dispenser. And then it says something about maintenance mode. You can enter maintenance mode pressing M, and the password is 123. And then, so you guys should have this PDF up and running now. And then here's the GitHub repository that they've given us access to. And then it looks like for the coin identifier, there is a table below that will tell us what the coins look like. So our goal, this is our project. The Vend International has created the hardware for this gum vending machine, and they've asked us to implement the software side of it and the logic part of it. And so this is what we're going to use to drive what we're going to build here. So I'm going to go ahead and copy this URL. And I tend to go too fast, so so if you need to, just tell me if I need to say something again or do anything. And it's obviously hard because we're not in the same room, so I can't really gauge the feedback there. But so I'm going to open up Visual Studio 2022. In this case, I'm going to say clone a repo in the top right. I'm going to paste the URL. And it sounds like somebody had a question. No? Oh, somebody joined. Gotcha. How should we handle it if somebody joins? I guess they can look into the chat and follow along there. Terrific. All right. I'm going to go ahead and pull down this repository. So our goal right now is to pull down this repository. And I guess if you want to, you guys can raise your hand or speak up if you're to that point. Thank you, Henry. Thank you, Paul. There we go. Thank you. All right. Well, we'll continue here. So now we have this project in front of us. And again, I don't know if all of you are trying to follow along or if some of you are just watching, but I'll just go ahead and go through the steps here. So we have this project. The first thing let's do is just run it. And let's see what we have here. Oh, and I need to increase my font size. I apologize. that things are small resolution. I'm on a Mac and I'm remoting into my PC, and so I can't change the resolution on this remote desktop. But I did increase this font size, and I'll increase the zoom of the text on screen here as well. Okay, so then 2000. That's checking modules. It looks like our coin identifier, storage, and gum dispenser are all malfunctioning, and so that's where we're starting. So here's our IDE. The first thing we can do is we can go over here and look at our modules. This is what they're going to have. This is what they're asking us to implement. So let's go into the coin identifier to start. And let me increase the size here. Okay, so you can see here that this particular method is not implemented yet. And now if we come back to our PDF, let's look at the requirements here. So let's tackle the coin identifier first. And so they're giving us information here. They're saying it must be able to identify all three coin types. There's gold coins, silver coins, and bronze coins. And then it says use the reference table below to figure out the width and the diameter. I'm sorry, the weight and the diameter. And then if a coin cannot be identified, it must return a type of unknown. So this is now where we're going to get into test-driven development, because right now we don't have any code done yet. And so I'm going to come over to our solution, and we're going to add a new project. And then up here, we're going to do a search for X unit. And there's at least 3 different types of unit test projects. There's MS test, there's N unit, and X unit. Those are the most popular that I know of. They're all very, very similar. So everything we're learning today, you can use any of those. I tend to use X unit, and there's not a huge reason other than it seems like it was most popular when I've just been out there looking at different things. And so, but again, they all work. They're very similar. Okay. And so now it's going to ask us for the project name. I tend to name my test project the same name as my main project that I'm testing with .test at the end. So we're going to say vend 2000 tests. And I'm going to keep it at 5 just because the project is 5. You can change that to 6 if you want to. Doesn't matter to me. And then we can actually even delete the first class here. All right. So now we have this test project, and we have Vend 2000, which is the main project. And so we're going to go ahead and add a new class. So you can obviously go to add class. I use if you see me doing this, this is an extension called add new file, and this would be a great thing for you guys to download if you guys like using shortcuts, because I can quickly add classes in here. So I'm going to add, so we're going to build test, and right now we're going to do it based on this module, the coin identifier module. So I end up naming my test coin identifier, tests, and it just gets us a regular class here. All right, so then let's go ahead and I'm going to come over to our PDF, and why don't I grab this text, because this is all the information I need to be able to, and the chart below, to be able to do this correctly. So I'm going to go ahead and copy this, and why don't we just paste it here, and then comment it out. All right, so now we need to look and see from this text what kind of test we need to do. And so what I tend to do is in this class, I will go ahead and say, okay, what am I testing? And so I'm going to be testing. We can see if we come to this coin identifier, we see that it implements this interface, right? So that's what they need us to do, is implement this interface and do it in a way that works, that is doing what they're expecting. So I'm going to create an object. I'm going to create an instance of our coin identifier that implements that interface. So I'm going to say coin oh, okay. So right now, I do not have a reference to that project, so it's not coming up. You can come over to your Vend 2000 test and add a dependency. You can add project reference, or as a shortcut, you can grab the project and drag it on top of the other project, and that will actually create a dependency as well. And so that's a quick way to do it. All right, so now I can come here and say iCoin identifier. And then the name of this variable, this is going to be a private variable. Let's make it private read only. And we're going to call this SUT. And so SUT is just a simple way. I've seen it called service under test or system under test. And so it's just a way, an easy way to reference the thing that we're actually interacting with. And so I'm going to say equals new an identifier. So now this is the thing. When this class gets fired up with the test, it's going to be using this coin identifier as our target for all of our tests. And you can see that we have some using statements that we're not using up here. You can use control Romeo Golf. That will clean up your using statements up there. And now we're going to get into our first test. So to mark a test, to mark a method as a test, we're going to use a decorator of fact. And then now it's not going to show. And what we need to do is add our reference to XUnit. So now we have our using statement for XUnit. And then a test needs to be a public void or task, public void, and then name of the method. Other than that, it's just a regular method. And so, and I know I'm throwing a lot of things at you here. When I name my test, so this is what we would usually call our method here, I will end up using underscores to separate 3 different parts of data. I say, what is it that I'm testing? And then underscore. And then I say, what is the situation of that test? And then I do an underscore and I say, what is the expected result of that? And that's what I do for the name. Now, I don't know what I'm going to name this yet. Can you guys look at this description here? What's something we can test? If we're saying, hey, we're trying to, if I handed this requirement to you, you start thinking about like, okay, what are the edge cases? What does that code need to do its job well? So you guys could just speak up. What's the first test that we can try?
To identify the type.
That's right. So it must be able to identify the type. And so maybe we'll work for gold first. We want to say, okay, if somebody gives me a gold coin, it should identify it as a gold coin, and that would be a successful test, right? So great. We're going to do that. We're going to say, now at this point, I say, okay, what am I testing? And I typically test it based on the method that I'm actually testing at that point. So we're in the class, and the class is named this, and then my actual method, I'm looking at more what the method is in here. And so I'm going to take a peek. So if you do hold down Alt and F12, you'll peek into to this class here. And so you can see that there's only one method in this interface, and it's identify coin type. So I'm going to copy that, hit escape to get out of there. And then I'm going to say, okay, that's the thing I'm testing. I'm going to do an underscore. And then I'm going to say, okay, I'm going to say with a gold coin. If somebody gives me a gold coin, right? So I'm going to say with gold coin. And then here's my result. What am I expecting from this? I'm expecting that should return gold coin type. All right, and so this is the only time I ever use underscores in my method names, but I've seen that as a convention, and I like it because it's separating these different pieces here. And I don't care how long this is because it's very descriptive. And so so that that's the rule I take, is that it should describe. Somebody should be able to come behind you and start to understand what this class does based on the names of what you have here, and then what this class can and can't do. So what we want to do now is break down this this method into 3 different sections. So, and they all start with A. So our first one is arrange. And it's hard to type when I'm typing in front of all you guys. Act, and then assert. Okay, so arrange is, in this, you don't always have to have these comments. It's just something just for us to understand what's going on. And so what we do at the start of the test is we say, okay, let's get the test ready. In this case, we need to get a gold coin because we don't have a gold coin. Then when we do our act, we're going to actually do the test. We're actually testing the thing and getting back a result, whatever it might be. And then we're asserting. We're saying, okay, after that transaction has taken place, what do we expect to look at? And so that's what we're going to build right now. So our first thing is we need a coin. So I'm going to say var coin.
Tyler, I do have a question.
Yes.
You have to ask anytime. So here I go.
Yes, please do. Thank you.
I see that act, arrange, act, assert a lot. I think that's like a pattern or something, right? Is that specific to NUnit, or does everybody use the AAA there?
I think it's everybody, just because it's just a way of organizing it. So it's not hard and fast at all, but it's just a way of because I've seen it around too, and that's where I started to use it. But it's a way just to organize it, because it's the flow that you would take through each test. but yeah, that has not won't matter if you're using X unit or N unit or any of those others. Yeah, good question. Thank you. All right, so we're going to create our gold coin here. So var coin equals, and then now if you came over here and looked at this world, we actually have these coins here. So we have a bronze coin, a coin type. We have a gold coin, iCoin, silver coin, and a wooden coin. So we're going to create ourselves a new gold coin. All right, so now we have that coin. Great. Now we can move over to act. And so act, we need to actually do the work. And so in our goal is to get this return type. So I'm going to say var, and I tend to just say result. Doesn't matter, obviously in regular code, I would always name this variable very specific to what I'm getting. If it's a person, I'm going to say it's a person or cat or whatever it might be. In this case, I tend to always say result. And along that line, tests are very flat, right? So dry doesn't, as far as my experience, dry doesn't apply here. We want it to be flat and obvious, everything we're doing. And so even if we have to reuse something, just again, make it so that somebody comes behind us, they see what it is doing without any kind of hidden tucking things away. We're trying to make it as obvious as possible. All right, so our result. So now what we have to do is we're going to go into our service under test. And then we're going to say, because remember, our service under test is the coin identifier. And this is the mechanism that a coin goes in. It has to tell the system what kind of coin that was. And so here's our identified coin type. And then we're going to pass it a coin we just created. And so now we're expecting, yes, I gave it a gold coin. I'm expecting this result. If I hover over it, you can see that I have a coin type. And if we look at that coin type, this is an enumeration here. We have unknown, gold, silver, and bronze. I'm going to jump back to that page that I was just on. And so I'm going to do a control tab. And you guys probably have done this all the time because we do it in Windows, but I do this a lot for jumping back because the back button will actually jump you to that line in code, which is sometimes nice. But when I'm toggling pages, it's nice just to do that. So if I do something that you don't understand what I just did, just yell at me and say, hey, what did you just do there? So, all right, now we have our return type here. And now it comes to the assertion. So we're going to say assert. And then what are we going to assert? Well, we have a few different options here. Null, not null, all these types of things. In this situation, we can say true. We're expecting this to be true. And then now we're going to create a true statement. Our true statement is that result should be equal to, and then gold. Okay. And then you can even go a little bit step further and you can actually put a little comment in here. You could say unexpected. So this is, if this is not true, then what are you going to say here? Unexpected coin, something like that. All right. Is everybody good at this point? I know.
Just a quick
yes
question for you. I noticed when you were scrolling through the options there under for assert, I think I saw equal come up, and I was just wondering why you.
That's a great question. So let's do both of those here. And actually, as I was typing this, I was thinking, oh man, equals actually equals will probably work well in this case as well. And we'll see the result. The message will be different based on those, because in this case, the assert only says, if it's not true, it's just going to say, oh, I expected this to be true and it was false, right? Where equals is going to give us a little bit more information. So again, I'm going to say keyboard shortcuts as I do them there, but Control D will duplicate. And the nice thing about that is that if I do Control V now, my clipboard is still intact. And so Control D will actually duplicate without killing your clipboard. And one other quick little thing, and you guys probably know all this too, if you're living in code here like this, is that if you have a single thing highlighted, you can see this gray line, this gray box around the line. That means that whatever you're going to do right now is you're going to do it to the entire line. And so sometimes, like we've all had it where this line is so long it wraps over here, and then you try to highlight it here or do the N button to get over there to highlight it. So anyway, that's something I do all the time, is that I'll just do Control D to duplicate it, or Control CV to copy and paste. And so that's just another little thing there. But yes, let's do that. So we're going to say equal, and then now it's saying, okay, well, I'm going to do Shift Control Space, and that's going to give me a prompt to say what these things can do here. So it's saying, okay, I want the expected first and the actual second. So expected is going to be our coin here, and then actual is going to be our result. And probably no special message on that one. Okay, good. So we'll keep both of those there. These will be doing the exact same test, but this will be good to see what the differences are. All right. So now we're going to go ahead and right click on our method name here, And then you're going to see here, it says run test. I have another run test because I'm running ReSharper, and so it has its own test runner, which I actually like a lot, and I can show that too. But but you guys probably see this one if you don't have ReSharper. And so we're going to say run test, and this brings up a test runner. All right, and so let me go ahead and dock this down here. So here's our first test. And again, we haven't written any code yet, any code in the implementation. That's part of test-driven development, is that we're trying to say, let's first get a pattern. Let's get an idea of saying, what is our goal, right? And in this case, we're saying, okay, gold coin goes in, gold coin type should come out. And that's what we're specifying based on the requirements that they gave us. And so the nice thing about that is that now you code as bare minimum to make this work, right? Because maybe you're coding too much and getting things to be too complicated if this was the only goal, right? And so that's where it allows us to do it very incrementally. So if I come down here and I look at our test, here's our coin identifier test, and then here's our identified coin type with gold. And you can see our message here is not implement exception, right? Which makes sense because we haven't implemented yet. So if everybody's good to go, we will go ahead and do our first implementation of that. So here's the identifier, here's the interface of that. I'm going to hold down Control so that I can go to the implementation and then hit F12. That will take me to our implementation here. So now I'm in the coin identifier. This is where we were hired to do this work. And so, and I love that we're in here. This coin, this method, this class couldn't care less who's calling it. We're in this little world now. So now we're saying, okay, we have a coin coming in. We know that it's of a iCoin type. And so if I take a peek at that here, an iCoin must implement a weight and a diameter. And so that's what I have coming in. And in this case, to pass our test, all I have to do, I mean, you guys could shout it out. What would I have to do to pass this test right now?
You need to have the type.
Go ahead.
Yeah, Ron's got it. Just return a gold coin.
That's right. Thank you. Gold coin type. That's right. All right. So now let's go ahead and so here, this is going to play all. This is going to run all test, and here's going to run a single test. So I'm going to run all, and that passed our test. And so everything's green here, and it doesn't give you information here. It just says that it passed. And so that's great. And so now, if that was our only job, then we're done, right? And so there was no complexity there. Again, this system is not being used, so you can do Control Romeo Golf, and that will clean that up. And so now let's go back to our test. So we did the first one, right? We said, okay, gold. Now let's go ahead and do it for silver. And so here's something that I tend to do. I'll do Control D here to duplicate this. And I know that this particular test here is identical to this one, except for, oh, and actually, you know what? Yeah, that's fine. The only difference between these is the word gold. And so I'll highlight gold. I'll hold down Shift, Alt, and then every time I hit period, it's going to grab the next instance gold. And so I can do that all the way through here. And then now I can type silver. And now we're ready to run this test. And so you can see that it came at the bottom here. It's already identified that we have another test, and I can run all now. And so this is you've heard red, green, refactor. Red is a failed test. Green means a pass test. And then you look at your code and refactor it, right? And so that's kind of the pattern that we're going through. So right now we did the first iteration of that. We said, hey, the gold coin worked perfectly. Now we added another test, and that's failing, right? And so now we have to go figure out how do we get both of them to pass. And so it's actually kind of fun in that regard. So this is what, I'm sorry, I didn't see any names when you were talking, but when you asked about equal versus true, the nice thing is that when we're just saying true, it doesn't know anything about whether, it only says, oh, this is true or false. And so it says unexpected token because this was false and it gave us this message. When you did equal, it gave you this information. It says expected true, actual was false. So that's a little bit better than just true or false, unless you wanted to have a specific message in there. I don't know if this one, I don't see this one giving you an ability to give a custom message there. So let's keep equal for both those. Perfect. So now we need to implement this in such a way that both coins will work. And so I'm going to go back into our implementation here. And so obviously you guys can do this however you want to do it. Let's just do it as an if statement first of all. So I'm going to say if coin, well, in this case, I'm going to say if coin diameter well, actually, I'll start with weight. So if we come back here to our document from them, they're telling us that a gold coin is always going to weigh 11 grams and a diameter of 30. So we're going to start with that. We're going to do, let's say, if the weight equals 11 and the coin diameter equals, what did I say, 30? Yep. Then we're going to, return a gold coin. And now obviously we have to return something. So let's say if it falls through here, we're going to return an unknown coin type. And then we're going to go ahead and do the same thing here. And we're going to say for silver, right? Because we don't know what the coin is coming in. We only know its weight and its diameter. And so we're going to say, okay, if it's silver, it's going to be 5 and 24. Then we're going to hand back silver. All right, I think this should pass now. So I don't have to go back to my test. I can come in here and just run this from here. It will build our project and run the test. And that passes. So now to get to the test, you can double click on this test and it will take you right there. One thing I'm going to throw at us here real quick is that I actually use a NuGet package that allows you to do your assertions fluently. And so I'm going to go ahead and just show you that because I like it and might as well tell you about it. So I'm going to right here, click on here. I'm going to say manage NuGet packages. I'm going to go to browse. And the package is called shouldly. It's like should with an ly at the end of it. And it looks like this. It has a checkbox. And so if everybody sees that, shouldly, and then install. And then now I'll go back to our test and I'll keep this one up here. And so shouldly, instead of us saying assert equal and then throwing in some things in here, I like it better because I can go right to my target. So in this case, I'm saying result should be, and then I can say it should be gold. And so that's the exact same thing, but I just like I like it hanging off of the thing I'm actually trying to test here, as opposed to calling a method and passing that in. And then let's run our test again, and we'll see the difference between them. should be or shouldly tends to give us a little bit more information, maybe only when it fails. Okay, sorry. Let me just make this silver. Run that. Okay, so the assert equals was that, and then this is what came from that other one there. But I just tend to sometimes I find that it actually gives me more information here. But anyway, I like the structure of it better. So I'm going to use that for these guys. All right, and then we'll do our final one, or not our final one, but we're going to do bronze real quick. Again, we're just going to do our trick here and grab silver and walk through silver and type in bronze. Obviously, some of this is just boring, repetitive here, but this is what I like about this is that right now we've thought through these requirements and we've figured out edge cases and all that kind of thing. And then next week we completely forget about it. But now we've left this robot behind here that's constantly checking our work. And so if somebody breaks something, it will let us know. And so I like having this out there. I read someplace, I don't know who said it, sorry, but they said that legacy code is any code that that you're scared to touch, right? And so with the test in place, you can make changes and not worry about them affecting the rest of the system, because as far as the system's concerned, nothing changed because you are still covering, you're still behaving the same way that you've always behaved. And so let's go ahead and finish this one here. Obviously, this is going to be a quick fix because all we have to do is add one more statement here. Is everybody doing okay? Is this an okay pace? Is this helpful?
Yes, good.
I'm
Great.
going to get shouldly to work. Was it the unit test coder shouldly package?
Let's see. So you went to NuGet packages and you went to browse?
Yeah, my shouldly does not look like that. Oh, I picked the one up below that one. Okay, interesting.
Yes. We want this one with the green check.
I see. Yeah, let me get rid of the other one.
Perfect. And just speak up if you need us to go back and look at how we made that test. All right, so now I have this in place. Hopefully you guys are all at the same place now. And we'll run our test. And then now we have the three the three things passing here, which is this first part of it. Must be able to identify all 3 coins of type gold, silver, and bronze, and then using the reference table. So that's perfect. So here's the neat thing about this, right? Is that now you've done this code, everything's working the way you expect. Oh, and actually, let's do one more. Let's finish that before I go to the next step there. If a coin cannot be identified, right? We need to do this part. So we want to go ahead and add another one specifically for saying, okay, I'm expecting an unknown because I'm gonna hand it something that should not be passed to it. And I noticed over here in the coins that we have a wooden coin, and so we're gonna hand it a wooden coin. I guess I should have changed that there. Wooden coin, and we're gonna say should return unknown. And again, this is readable, right? So if somebody comes behind me, they can say identify coin type with a wooden coin should return unknown type. And so so that makes it clear that somebody says, okay, well, what are you testing here? And we try not to test big differences. Sometimes I'll put multiple asserts if it's testing kind of the same category of things. But if it's going to be something that is really a different test, I would end up making a different test out of it. And that's where these pages tend to get a little bit longer here. ReSharper shows me a list of them here, which is nice. But that's to be expected as far as we don't want to pack it so much into one that all of a sudden now it's testing multiple things. Okay, so at this point, I'm going to come in here and create a wooden coin. I'm going to pass that in, and I expect it to be unknown. And because the way we built this already, this is actually going to pass right away because we said, hey, if it falls through these guys, we're going to pass back an unknown. So let's give it a try. Perfect. All right. So there's one last thing we can do, right? Is that we have this wooden coin, but what about creating a dynamic coin, something that we can throw a bunch of values at, right? Maybe it's all these different diameters and weights, and we should get unknown, right? So we're going to kind of brute force, throw stuff at it. So let's go ahead and duplicate this, and let's say with dynamic coin, and we don't have one yet, but let's just make one. All right, so we know that these coins all implement the interface of iCoin. So I'm going to come here and create a public record called dynamic coin. And it's going to take an int, which is the weight. It's going to take an int, which is the diameter. And we're going to implement coin. Okay. So instead of this wooden coin, I'm going to say I'm going to create a new dynamic coin. And then we have to give it a number, right? So this is the weight, and this is the diameter, whatever it might be, and then that should be unknown. So we're going to go ahead and run that, and that's perfect. But we look at this and we say, okay, well, I don't want to just do one. I want to be able to actually do multiple ones. Maybe, I don't want to have to come in here and duplicate another one just to say, okay, I want to try it with what happens if it's 0 weight. Do we have a problem with that? Should we have a problem with it? They didn't mention anything in the requirements for that. So our goal is to say, okay, let's pass this in as a parameter instead. So I'm going to copy our weight and diameter and make these lowercase. And then now it's saying, oh, facts cannot have method parameters. So what we can do is we can change this fact into a theory. And what a theory allows us to do is pass in parameters here. And I've noticed that they're primitive types. I haven't played with it too much, but I don't think I can pass a class, but I can pass in these parameters here. So in this case, I want to say here's going to be my weight, here's going to be my diameter. And then what you can do is you can, in the decorator here, you can say, I'm going to hand inline data. And that inline data is going to take a collection of objects. And so in this case, we're just going to pass it in like this. So it's going to be 23, this, right? Something like that. And so we can say, okay, well, maybe it's 200 whatever and this. And then we'll do one more. If we say, okay, do we have any problems if it's 0? And so then now we can run this like normal. And you'll see that this actually gets a nested thing. So it actually is trying each one here. And so that gives us a good coverage of this module. There's not anything else I can think of that we would test just based on these requirements. And so the final thing that we can look at this and just like we said that this code here is protecting you now, right? And so you can go ahead and continue to make changes, and it's not legacy code. You're not afraid to touch code anymore because our tests are covering us. So what if I came into this and I said, oh man, you know what? It'd be nice if why don't we use a switch expression here instead? So I would just come here, change it to a switch expression, and then run my test again. And if it passes, then I know I've got all my cases covered. And that's the real beauty and heart of this whole thing, is that it allows you to make changes internally and not worry about your external signature changing and breaking something and having a ripple effect. So that's the beauty of that. And then maybe you can change this to a dictionary, or maybe you pass it into, maybe make it something with a strategy pattern and pass something in. But this gives you the freedom to do that. So that's the first module. Any questions?
I like all those green check boxes.
It makes you feel good, doesn't it?
It does.
I've never used the theory before. In fact, I didn't know there was such a thing. So that's really interesting. I got to thinking about it. What if you passed in the weight and diameter for a known coin in there? And anyway, I tried it. It fails the test.
That's right. That's a perfect test. Yep. Because we're expecting it to be unknown and it wasn't unknown. Yeah, that's great. Have you guys done unit tests before? Or is this kind of our first dive into it?
Well,
No, I use all the time.
Yeah, I can confess. I do unit tests, but I don't do them before I do the code. I tend to, just before I do a PR, I'll write the test for whatever I was just doing.
That's right.
Whatever I was just working on.
And I know that's how life goes, right? And just their job and having to do that. And I know that people say, and you know, I guess I'm kind of getting there, is that people say that they're just as quick or quicker when they do it this direction. I can see that, because then you're really going into code and you have a very clear idea of what you're trying to do, even if it's small incremental things, right? Just like when we passed back the gold type only, it's like, okay, I have a very clear goal in mind. And then now you can add on to that and keep layering and end up with code that's probably a little bit more trimmed than if you just went in willy-nilly and didn't have any kind of idea of what you'd have requirements, but you know, this is us sitting down and thinking through and then putting it into actual systematic approach to figuring out if it works or not. So I know sometimes it's weird, like, okay, well, I know there's no code, so I know it's going to fail, but like it's a good habit to get into, just to see it fail, because the other thing too is that you don't want to have a false positive, right? You don't want to be able to say, oh yeah, it passed, but then you realize, oh, it passed because I never got to that part of the code, right? And that kind of thing.
So when you added X unit, did you add it as a NuGet package or as an extension? I don't think I was paying close attention.
I added it as a project. So I went up to the solution and I said, add new project.
Oh, and it was one of the default types?
Yep, that's right. So I went to new project, and then I did a search for unit, X unit here, and then I just added it as a project.
But I asked that because if somebody here is not yet on 2019 or 2022 for some reason, they might not see that project type in there. They might have to go get an extension to get it to show up.
Oh, that's a good point. Like 2017, you think it wasn't in here as a project?
I'm not sure if it was in there for 2017.
Yeah, you're right. That's a good point. Yeah, so hopefully everybody was able to find that X unit. Terrific. So now let's go ahead and run our project. And we have a little bit of progress here. We passed the first one. So we can't use the vending machine yet. Oh, I didn't even look at the time there. How are we doing on time, everybody? So another half hour?
Yeah. Mm-hmm.
All right. We may not be able to finish this together, but at least we're you guys could finish the third module if we don't get to it. And hopefully this, the application will actually, so that's the other thing too, right? We're doing this code. The vending machine company, we don't have a vending machine in our house. And so we're doing this code and we're actually doing it almost blind in that regard, but they can take our code, put it right into the vending machine and have it work because we've covered everything that's supposed to be done through the interface. And so that's the neat thing. So without you even looking at the code that they created, you'll be able to run the machine. And I'm hoping it works. It was a little while ago I made that little console, so hopefully it still works. But as far as your job's concerned, you just doing everything through test here, you will actually fulfill everything so that machine should be able to run just out of the box using your code. So that's what we're going to explore here. All right, so let's do the next one here. Everybody's up to speed as far as everybody's at the same point with us now? Everybody got the coin identifier to pass?
Yep.
Terrific. All right, coin storage. I'm going to copy this and do the same thing we did before. So I'm going to go over to my tests. I'm going to use my shortcut, Shift F2, and this is add new file. So I'll just show you this real quick since this is fun for us here. So if you go to your extensions and manage extensions, and you go online, it is called add new file, I believe it is. It's right here. And I use this all the time. So creating folders and things like that. As you can tell, I love shortcuts. And so like if I want to make a folder here, I would do F2 and I would say folder name /test.cs. And then now there's my file and there's my folder. So it's just so much easier than right clicking and clicking and then choosing a class and that kind of thing. So anyway, I highly recommend that little extension. That's the first thing I install when I get a new version of Visual Studio, and then restart or maybe not in that order. All right, let's go ahead and add our next test. So we are testing coin storage. And so I'm going to do the exact same thing as far as my naming convention. Coin storage tests.cs. And if you remember, well, let's go ahead and paste our little instructions here. And then the first thing we could do is we can go ahead and create a private read-only. Doesn't have to be read-only, but squiggly lines if not. Private read-only, and then what we're testing is going to be an iCoin storage. And we're going to call it SUT, service under test, and we're going to say new iCoin storage. And this gets used when the test runs. It actually uses this one, and it uses a brand new one every time. So if you have 15 tests, it's actually going to use brand new one. This does not go from one test to the other. So if you make a change to this one, you're not going to see it in the next test, which is good. And you want those tests to be independent, and that's what's happening here. All right, I'm going to do. I don't know if this. Oh, I guess it's. Anyway, I'm just going to do Control-R-G to clean that up there. And that could have been Control-K-F, I think, for format. I have it mapped differently. All right, so now we need to do our first test. And so again, we are going to start by decorating it as a fact. And then it's going to be and then we're going to go ahead and add our, oops, we're going to, oh, hello. And import our XUnit up here. And then we might as well add shouldly as well, but we can get that later. All right, and then remember it has to be public, and it can only hand back a void or a task. And then now we're going to name it. So now we have to look at this description here. So what do you think, what should we tackle first? And what should we name this guy? Let's tackle this one first. So what should we name it? Actually, yep.
So I guess it would be identify storage.
Yeah, let's see. So we'll tackle this one, right? So capacity. So how about this guy has...
Should we peek at the iCoin storage interface first to see what it has?
That's right. That's perfect. I mean, just because I don't know what it has either. So I came in here. And so you're right. So it looks like we have
capacity. We need a test to test capacity then.
That's right. Yep. Perfect. And so let's go ahead and do that. So we're going to say, I'm going to test, in this case, it's not a method, but I'm just going to say capacity. And then I'm going to say, must have the capacity to hold 100 coins. So, and in this case, I might actually only have two pieces. One I'm testing, and then there's not really a setup. Well, let's just say with 100 with capacity should hold, or should be 100, should hold 100 coins. Great. All right. So I'm going to go grab the assert just so we have it. Oh, okay. So I just hit Control-C right now, right? I went over here, I grabbed this over here from in my I grabbed this in my clipboard, I came over here and did Control C, right? And so that obviously clobbers it, just like as you guys have probably done and I've done. And so this is the other thing I love using in Visual Studio is that if you do Control Shift Victor, that will get your clipboard ring. And so in this case, here's my here's the last thing I copied there. And so that's something I use all the time as well. And so sometimes you might go over to something else and actually say, okay, I want this, and I want this, and I want this, and then you can jump over to here and then unload it, dunk, 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 in the same way. It doesn't make that sound though. All good though. All right, so let's just comment this out for a second here. All right, so we have our arrange. I guess I can just get rid of our. All right, so our arrange. In this case, I don't think we have an arrange, right? We don't have to set anything up to see if this device has a capacity of 100, right? So I think our only thing we need to do is we could grab that count. So we can say var result equals SUT.capacity, right? And then we're going to assert it, and this is using shouldly. We're going to say result should be, and then we're going to say it should be 100 because that's what our goal is here, right? And then now if we go down here and take a look at our test explorer, we see a whole new section. So this was for the old one, and here's our new section for our this test that we're working on here. So let's go ahead and run that. And obviously it fails, right? Same thing, not implemented. Great. Let's go ahead and Control F12 will take us to the implementation, and we can see that this is what the class looked like when they gave it to us, right? And so in this case, it's easy enough, right? We can just change that to 100 because we say, okay, this particular code is going to hand back 100 each time. So let's go ahead and run that. Perfect, easy one. So that's a pass. So now let's jump back to our storage, and let's duplicate this guy, and let's think about the next thing we're going to test. So we did this one. So let's just tab this guy over here. must be able to. I mean, we can't test emptying until we add. So let's do this one next. Must be able to add a coin. Okay, and if we just as you mentioned, if we peek at that interface, it looks like we have an add. And we have a coin count, and that's how many coins are in the box. But we have this add, and it hands back nothing. So for us to pass in the coin, we want to put the coin in and then check the coin count after the fact, right? So we could even, you could check the coin count before and after if you wanted to be double sure there. So let's do that. Okay, so why don't we capture the count ahead of time? So we're going to say var coin count before add equals SUT, which is the machine that we're testing, and then we're going to say coin count. Okay, we're expecting that to be 0, so we can actually add that to our test. And then in our act, oh, I'm sorry, we should name this. This is going to be add. That's the method name that I'm testing right now, and add with 1 coin. Should add coin. All right. Here's the coin count before, and then what we're going to do is we're just going to say SUT add. Oh, I'm sorry, we didn't build a coin yet. So let's go ahead and create a coin. Var coin equals new, still wooden coin this time, and we're going to pass it here. Now this wooden coin, if it was going through our identifier, it probably wouldn't allow it to come in here, but that's all right. It doesn't matter for this. We're going to say add here. So now that we've done an add, we can test 2 things. We could say, okay, well, 1, I expect after this is all said and done, I expect the coin count before add should be 0, and the coin count after the add, we can say SUT.coin count should be 1, right? So now obviously we're going to run that. It's going to fail. We're going to dive into our code, and we're going to implement it. So we need to, and again, it doesn't matter the mechanisms we use inside of here, as long as we're exposing the right things and handling things the right way on the outside. So coin storage, let's create a list to hold our coins. So we're going to say a private list of type coin, or a type iCoin. We'll call that coins. And we'll just create a new list of it. Great. And so I'm going to say coins dot add, and I'm going to grab this coin. Perfect. And we're still going to fail because we're not, we know that we're testing the count, right? And so the count hasn't changed yet. So what we could do is we could say, all right, when somebody asks for the coin count, we're going to hand them back through this Lambda expression, we're going to hand them back the coins dot count. Great. Oh, this could be read only, and we'll run it. Okay, great. Let's go back to our test. All right, so we have this one. I can collapse that up. Add with 1 coin, and then it gave us the right results here. Coin capacity, must be able to add a coin. As far as I'm concerned, I think we're good there. We could add multiple coins if we wanted to, just do a quick test like that. So I'll just do another one, and I'll say with 10 coins, should add 10 coins. I guess I could have written this out here. All right, and then I can, instead of doing this guy, I'm just going to say, say 10. All right, and then we're expecting 10 coins to be in there. Clean this up a little bit and run it. Okay, good. So are there any other tests that you can think of that would cover this whole idea of adding?
How about add 10 when you start with 97?
Ah. Did this mention anything about, I think you're right. So if somebody tries to add, if we get it to 100 coins and we try to add more, we shouldn't let them, right? I didn't have this as a requirement here, but I think that's a great test to do. Okay, good. So we're going to say, more or less, you're saying if we're at capacity, what should happen, right? Add with 100 with 101 coins should. How about with 100 coins should not add coin? Okay, so we're going to say that we're going to add 100 coins, and this can now move up into our range because we're before we test the thing that we're testing, we're going to get it ready. Then we can add a new coin. That would be our 101 coin, right? And so then we're expecting that there should only be 100 in there. So that's a good test. Okay, so let's try it. And why did that fail?
Our implementation just added it to the list.
That's right. Yep. And so if this was one of the requirements, and I think it should have been a requirement. I think I missed that. Is that we should come in here and now say if capacity. Let's say if coin count equals capacity, then we're just going to return. All right. Perfect. All right, we're looking good there.
Nice.
Yep, good catch. That was something I think I tested on that before this, and I didn't remember that I didn't have it as a requirement. All right, so okay, so we can add a coin. Now we want to be able to empty a coin. I keep cleaning up the thing, and that's why it moves back here. Now we want to be able to empty a coin. So let's go ahead and copy this guy. We're going to say empty. And let's say empty with 100 coins, or let's say empty with 1 coin. That's fine. Empty with a coin should empty coin. All right. And so we're just going to get this guy ready. We're going to put 1 coin in there. And we don't have to test that anymore. We're just going to add 1 coin. And we know that that's working in our other test. Our other test is covering that. So we're going to say 1 coin. And then we're going to say the result, our result equals SUT empty coins. All right. And what should I assert here as I take a drink of water?
We should have 0 coins remaining at the end. It should be 0.
That's right. Yeah, and we can test 2 things, right? We can check to see if the SUT has coin count of 0, and we can also test that this one has a count of 1, right? So we'll start with that. We'll say result dot count should be. Look at that, it's prompting me for it there. Nice. And then we can do the other part of it, which is that the SUT dot coin count should be. Actually, I told you wrong there. So that should be 0, and that should be 1. Perfect. Let's try it. And I tend to run, even though I could click on this test and then just hit play, it would just run the test that's under my cursor. I do them all because sometimes you fix one and it breaks another one. And so you want to constantly be testing all of them. And one little side note is that one thing that I like about ReSharper is that I have dot cover. And so I have the unit tests in here typically, and then dot cover, anytime I save my code, will actually rerun my test. And so when I'm in kind of a test mode, I can turn that on and off. And so I'll be doing this and I'll jump back. And so I'll just jump into this code, hit save, it'll run all my tests, and I can see what happens there. And so it's a nice tool to have if you have ReSharper already, or a subscription to the ultimate whatever package they have there. Okay, good. So this doesn't work for us. And so we're gonna go into our empty coins and implement that. And so in this case, we know that our coin count is going to get affected here, so we don't have to do anything there. But we can't just say return coins here. We can't do that. Why can't we do that?
Because we have to figure it out.
Sorry, what's that?
So just returning the collection doesn't empty it.
That's right. So then what should I do? Would if I try to empty it here? That's not going to work, right?
You need to put it in a temporary variable of some sort.
Yep. So let's do that. And then what we could do, we could also make a copy of them, right? So then that way we don't have any references to it from that. So let's just do that. Let's say coins to return, and we're going to say coins dot select, and we'll see. I think I just do that, right? Yeah, it's all good. And then I can just do that and coins to return. But sorry.
You could have just returned the existing one and created a new one. It created a new list for this guy and then return the existing list.
Create a new list of this for this guy?
Yeah, so basically so basically point to the current list.
Okay. Oh, point to the current list?
Mm-hmm.
Okay.
And then set the current coins to a new list.
Okay.
And then return the test.
Ah, interesting idea.
That way you're not copying the list that you're not even going to need.
Okay, so right now it's read only. That's the only difference there, but I like that. Interesting idea. I like that. And so, well, that's the cool thing, right? Let's try it this way. Run it. Again, this is the beauty of this, is that it lets us have the freedom to try different things and say, okay, as long as it passes, we know we're good. So so I like your idea there. So now we have this, and then let's say this is this, and you pointed a reference to that existing one, and then you created a new reference to that one, and we can test it again. Nice. I like it. Well done.
Nice.
That was pair programming right there. Okay, good. Let's see, what else do we have on this one? Okay, so empty. I think that's it on this guy. We emptied it. We still kept the count the right way. I think we're looking good. All right. Time wise, 4:30. Was it 7:30 for you guys?
Yeah, I mean, you know, it's somewhere around there. Not exact times.
All right. Do you guys want to go to questions, or do you want to try to do the last module?
I do have a question for you while we're trying to decide, if you don't mind.
Yeah.
I noticed that the classes that we're testing don't have any dependencies. And I was
That's a great
thinking, like,
question.
a lot of times
Yeah.
you'll have dependencies that are either injected, or maybe you know,
Mhm.
when you're newing up something, you've got to pass in something in the constructor. And I was wondering if you had any strategies for handling that sort of thing.
Yeah, that's a great question. So you're right. In real world situations, we're going to hit that a lot, right? And that's the beauty of it. So I wonder if I have our project I can just show you. So the way that I handle that is let's okay, so here's iCoin that's doing that. Let me just think about. So what you're asking is to say, okay, we have to spoof our dependency injection, right? And so we might have to do something like this, where we're saying, hey, I need you to hand me an iLogger or something, right? And then now we're gonna have to use that in our code down here. So we're saying, okay, or in this case, maybe it's a gum packet such and such or whatever, right? And so you need to pass that in, and then you're going to use that in your code. And so I didn't plan on going into that for this particular one. Because it's obviously we're going to get our time anyway. But what you're looking for is mock, and so so what I end up using is something called MOQ, and it's a NuGet package. It looks like this, and what that allows you to do is build up. So because we try to do everything against the interface instead of a concrete class, somebody might say, hey, hand me an iPrinter, whatever it might be, right? And that printer should have the ability to print and should have the ability to turn off, something like that, right? And so in our code, real code, we would actually have a concrete object that was actually being handed us, and it can do those functions, right? And so what mock does is, in our test, lets us construct that the way we want to. And then what we do is we use it in our test, because then we can say, okay, let's say that print, it's turned off or whatever. So you're able to mock that object that gets passed in exactly the way you want it to be. So then you can see how your code behaves when that goes into that black box, and then now interacts with your code, right? And so you get full control over it. And so it's been a really neat thing. And so yeah, I use mock all the time. And so that's a great question. Did that answer your question, kind of?
Yeah, it does. Thank you.
Perfect. But yes, that is a real world scenario for sure. All right. Any other questions, or should we try to tackle this in a couple minutes here?
Let's do it.
All right. We're gonna do exact same thing here. We'll come over here. We're gonna say gum. What is this called? Dispenser. Tests. All right. I'm gonna paste. Obviously, this is a little bit of rinse and repeat. And as you saw, we run now. We get 2 of these modules, so we can finish this last module here. Okay, so in our gum dispenser tests, let's just bring over some of our code from our other one just to make it a little bit quicker. Or if you're following along, you can do it there. So now we're going to change our this to a gum dispenser. Equals new gum dispenser. And then we can peek at it just like we did before. And it looks very similar to the storage. So we have a capacity, a quantity, an add, and a dispense. So great. There's not going to be a huge amount of new things here, but let's go ahead and must be able to hold 20 gum packets. So let's do that same thing with capacity. Should hold 20 gum packets. And capacity, shouldly needs to be added. So I'm going to add that. Should be 20. And we're going to run it. It's not going to work for us. I'm going to go into it and say 20 and run it again. All right, great. So now the next thing we're gonna look at, we'll just finish this up here real quick. Must be able to hold 20 gum packets. Must be able to dispense a packet of gum if available. So, but we want to add a gum first, so maybe we'll do that one first. And then it says mechanism should not break if we try to add or dispense either when it's full or when it's empty. We don't want to throw an exception. So let's go ahead and add a gum packet. And so I'm going to arrange it. We need to have a gum packet. So we're going to say var gum equals new gum packet. And then now what we're going to do is we're going to add. So we're going to say sut.add. We're going to pass our gum packet in. And we're going to assert that the sut.quantity should be 1. And we're going to say add with 1 gum packet. Add. Okay, we'll run it. Doesn't work. No surprise there. And so you guys just implement this just like I am, as quick as you can. I'm going to store this in a stack because it seems like a magazine of gum in my mind. So I like that. So I'm going to say private stack. Okay. Gum packet. I don't know if we put a number in there if it would actually create empty ones or if it's like an array where it just create that many slots. So I don't know. We'll see. Oh wait, what did I do there? Oh, there. All right, so our add and then our quantity is going to be the same thing. It's going to be gum packets dot count. And then look at this one. Now in this case, the reason that this makes sense is that to me is that we can pop one off. So when we're dispensing one packet at a time. So we're going to say add. We're going to say gum packets dot push gum packet. Okay, I'm going to run our test. And we're good. Now let's do dispense. And obviously you could do 2 gums and, oh, well, actually we need to do the other test, right? So we needed to say when you're at capacity, it should not crash if it has too many. Oh, and actually we could, I think this would limit our, I guess that would have to be static there. All right, that's fine. Okay, so we're going to say add with gum packet. Add 1 gum packet when full. Should not add gum packet. All right, so here's our range. What we're going to do is we're going to do a for loop. We're going to say sut.capacity. And then we're going to add a new, we're going to do a sut.add. And we're going to say new gum packet. We're going to add however many are there. Then in our act, we're going to try to add 1 more. And we're expecting it to not crash, and we're expecting the quantity to be exactly the SUT capacity. All right, and we'll run it. And that should fail. But the nice thing about these tests is it gives us a good handle on what we're actually trying to do. So that's what we're doing here. So then now I'm going to say if capacity equals quantity, then I'm going to return. Run it. Everybody's happy. And we'll do 1 more test. We're going to do our dispense. We're going to say dispense. Oh, I guess we'll do 2 more. Dispense. With one gum packet should dispense 1 gum packet. Okay, so our range, we're going to go ahead and give it a gum packet to have in its system. And then we're going to say var result equals SUT dot dispense. And we know this could be null. And so in this case, we have with 1 gum packet, we're expecting this to come back as a gum packet. So, oh, and actually that's one thing that we did. We never tested, we'll test it here. What if somebody gives us a null right here? That would probably break. So we should add that as a test too. Okay, result dot should be, and we should say, we could either say type of, right? We should say should be type, and then you could say what type are we expecting. I think I could just do it like this and say should be of type gum packet. And so let's run that, and that's going to fail. Oops. And so what I'm going to do here is I'm just going to return gum packets.pop. And that passes for us. Obviously, we need to do the next thing, which is to say, okay, what happens if we dispense? We dispense with when there's nothing in there, right? So that should give us a problem. That should give us a null with 0 gum. Should not break. I think that's pretty technical. Should not break. Get rid of the range. And now we should just have a problem. Okay, great. If I come in here, it says get through for empty stack. So I'm going to come back into here. I'm going to say if quantity is less than or equal to 0, should never be less than, return null. Okay, I guess we could let ReSharper do this for us. All right, let's run it. Oh no, still failed. Should be of type. Oh no, that's actually right. We expect this guy to be null. So should be null. But there was nothing in there, and so we'd get a null back. That's what the system's expecting. Perfect. And then we also wanted to, well, we added, and we saw that the quantity was covered there. And then we removed until they were gone, and shouldn't give us an error, and that was fine. And we could even dispense multiple, that's fine. Okay, so the last thing that I was just thinking of as we were building this is that somebody could hand us a null object here, right? So let's say an add. So what we would want to do is that in this case, we want to add with null should, and now, so here's something new. Should throw, let's say in this case, we actually want them to throw, because this is a system problem for us, throw argument null exception. Oh man, it's hard to type when you're exception. How about that? All right. So we're going to hand them a null here. And get rid of this. Okay, we're going to hand them a null. Doing the nulls are a little bit different. I think I forgot to check this. I haven't done this for a while here, but I think shouldly will be saying should cert exception. No. I have to remember how to do this now. Because what I would do otherwise, if we did it without shouldly, it'd be assert
dot throw.
Assert dot throw. Yes, thank you. Assert dot throws, and then you'd say argument null exception, right? Argument null exception, and then you pass it in a lambda expression here, what you're trying to actually test. This is an action here. And I don't remember how to do it on Shoodly. I can just look it up on the internet knows how to do it. But anyway, let's just do it this way. So, so when we're testing, we actually want to test for exceptions as well. And so that's how you would do this here. So let's go ahead and run that. And it expected a throw of this, and there's no exception thrown. So let's go ahead and do that. And we could say if gum packet, there you go. Do we have his null in 5? If argument. You could say something like type name of. All right, I think we're golden there. Good. So I think that's all the things that we'd be testing for. Does anybody have any other tests that they thought of when they were looking at this that would be a good thing to add? It doesn't break. That's good. Be able to add, able to dispense, hold 20. I think we're good. So now let's run it. And again, I don't know if this, it's been a long time since I touched this console app. So if it's broken, that'll be a task for you to fix it on your own there. But so right now we can come in here and it's asking for a bronze coin. So this is going to use our coin identifier, of course. I'm going to give it a gold coin and it says invalid coin and then coin was returned. I can give it a silver, same thing, give it a bronze and then clunk gum packet defense. And so at this menu, remember they said that we can go into maintenance mode by hitting M. And then the password is secret, it's 123. And now we're into maintenance mode. And so now this is our whole coins and our mechanisms here. And so it says gum packets 0 of 20. And I don't think I loaded it before, so I don't know how we got gum out of there, but let's say we're gonna load it. And so now we're loading up and it gets up to 20. And there's no error, which is great. So it just can't fit any more packets of gum in there. It's only got one coin count in there. And so we're going to dispense a coin, dispense a gum packet. So that's working. We're going to empty the coin storage. And then now we have no coins in there and we can exit exit maintenance mode. Apparently I can't, but you got the idea. And so anyway, so that's the console app I created to make this a little bit more hands-on and a little bit more fun to try to work through. And so the cool thing is that we never touched the code that ran this console app. We were able to do all the code ourselves and just do what they asked us to do. And then it fit without us even having the machine in front of us. So yeah, so that's it. Any questions?
No, it's great. I kind of feel like, we have code, like I keep thinking about Visual Studio 2022 and, the GitHub Copilot. When can I get something where I just can right click on a, project and say create tests and just kind of like use AI to figure out, like at least get me started with the tests. I know Visual Studio a long time ago, really old versions of Visual Studio. Back in the full framework days, you could do that. You right click on a project, and right click on a class.
Yes, you can do that. I actually have never tried it before, but you can do something like that. It will stub out some of these facts for you, right?
Like require the enterprise license.
Working recently.
Yes, I haven't
that
for
was
a
in
while.
the old team system, and then they moved it to enterprise. So you have to have like enterprise to get it, I think.
Yeah, something like you come in here and you could like say, "Oh, here's create unit test." Let's try that.
Oh.
I'm on community. So it looks like
I think that's just going to create a stub for you to start filling out, so you don't have to make the entire structure of the test.
Yeah, that's right. Are you saying that it actually with the enterprise it actually does more than that? It wouldn't know what we're trying to do though, right?
Oh yeah, enterprise. You can even peek at code that you don't even have the source code for.
Mm-hmm.
It's pretty cool.
Resharper lets us do that with.
Nick Kappas does a lot of examples with it, I think, on YouTube.
Okay, nice. Yeah, that's a.
I'm not a big fan of auto generators, largely because I don't trust Visual Studio to ever understand that my models are not that simple.
That's right.
But if you've got something that's very simple and predictable, yeah, I think that's something what we should be able to do at some point.
Yeah, or if it just gets you a starting point, like so you don't have to, a lot of it's tedious, right?
Point. Exactly right. Go ahead and create that, class with that object in it, and then scaffold out the, your arrange, act, asserts. I don't know, like do something to help. It would be really, really nice to have.
One thing you can do is Visual Studio for a long time has the ability to create templates that you can then set up with like a key code, like a snippet. And if you type like
so
or something, and it'll just bam, put out the method there, and then you can have placeholders to change the name of it, maybe change the name of the variable you start with. I do that all the time. I'm always creating templates, and it makes me faster.
That's right. Yep, that's exactly right. I know that Visual Studio has it built in, and I don't remember exactly how to change it there. For Resharper, they have a whole thing. So like when I'm doing I don't know if it's going to work in here because I have it. Nope, I have it only for the other.
Snippets, I believe you can go under there and you can see where
is it?
Tools and snippets, I believe.
Tools.
Code snippets manager is what they call it
now.
And I go in there and I find one that's sort of like what I want, and then I go find the file. I open it in Notepad++. I give it a new name right off the bat, what I want it to be, and then I start changing it, and then I open in Visual Studio to make final modifications.
Nice. When I do it through Resharper, so like pretend like I wanted to build this structure right here, right? I would come here and copy this, and then I go to Resharper and Tools and Templates Explorer, and then I would say New Template. That's fine. Actually, let's do C#, New Template, and then I paste it, and then just like what you mentioned, I would clean this up the way I want it to, right? And then like maybe I would say something like this, method or something like that, right? And then I could do that for this one, something like setup, whatever, right? And then so on and so forth, right? And so then we keep that, and I can go throughout the whole thing there. And then when I come back to our test here, actually, and then let's say I said underscore test, and then I'll save this, and then now I can go into my test here, and so then I come here and I'd say underscore test, and then there it is, and I can start typing there, and then I hit tab, it takes me to the next one, and then I could keep on doing that all throughout there. So yeah, that's a great thing. I love using that. And so did you said you had to go into like Notepad++ and then copy over into some folder or something like that for the other one?
Yeah, the main reason I did that is because I was curious where the snippets are being stored, because I wasn't sure if they were being stored locally or in my shared user folder that was on the network.
Yeah, that'd be great to store them into a repository so then you can have them and make sure you don't lose them.
It's interesting. I don't see that option. Can you show me that create unit test option? What did you click on? What did you right click on?
What I just showed you right now was Resharper, so you may not have that.
Right. No. Earlier when you were showing that option,
tools, and then code snippet manager. Control K, Control B.
Even before that,
dialogue, right?
When you said there was something that creates unit tests.
Yeah.
When you right click
on mine.
When you go into the modules and go click on like coin identifier and then right click on the method. And then down here.
Oh, you right click on the method. Hold on, let me go do that. Right click on the method. Yeah, okay. You know what? I was right clicking on the class. I think
that looks like it works too. At least the class name up here.
Yeah, I think if you do it on the class, it'll try and stub out for every method at least one test.
Oh, yeah. No, I was doing on the file, like on the
yes,
file,
over here. Yep.
What I don't know is
definitely not working. This is great. Okay, thank you.
Will it go to a new test project that's MS test, or will it go to the XUnit test project you've already set up?
I think it'll go to a new MS test. Let's try it.
So that's why you might want to go get an extension.
Are you serious? It's not
create new this, and then you choose which type. And
yeah, because you're right. There might be. Oh, it says right here. Get additional extensions.
Oh, okay. Oh, look, the example shows XUnit, which I'm guessing.
Right.
a lot of people go to. If they come here, that's what they're looking for.
That's right.
That's funny.
I'm
Okay.
old fashioned. I like in unit.
Oh yeah, yeah. I mean, like they're very
But there are
similar,
some
aren't
things
they?
that MS Test lets you do that you can't do in unit.
Oh, interesting.
X unit generator. Got it. So find and install frameworks. So this must be something you install at the Visual Studio extension level, I'm guessing.
So this is what it created for me in MS Test. And so same thing, we have an assert, we have a class name or a method name, and then we have this is what we would call fact, and then this is what they decorate the class itself.
Can you right click on the code, the project there for a second? Yeah, I don't see you have it there. There is also an extension that, like, if you go to add, instead of having to go to new item, it'll have a list of all the different test types that you want to create.
Oh, right.
Create it, but I can't remember the name of it. I went looking for it a moment ago and couldn't find it.
Right. Nice. Yeah, I don't see anything else there. Good.
Wow.
Well, did you guys learn something? Hopefully there are some tips there that you think.
Oh yeah, absolutely. Thank you so much, Tyler. This was very eye-opening. You know, I do unit tests, but I like the TDD approach a lot, where you do the tests before you do the actual coding. It lets you think about it better, and it's actually you're already ready with a test, so that you can immediately start testing your code you're writing without getting far. You know, that's all the.
That's right. It kind of keeps you on track too.
Right. Yeah, absolutely. Because it doesn't matter how good of a programmer you are. It's easy to make mistakes. So every piece of code you write needs to be tested. And what are you going to do? Rerun your application and figure out a way how to call that code? No.
Right.
So write a unit test. You can just test out one piece and then move on without having to run the application every time to debug it and get that code back. This is fantastic.
I should have mentioned that I can't see the chats while I was sharing. So if anybody said something in the chat that you wanted me to, like, hey, why aren't you doing that or whatever, I didn't see it. So sorry.
That's all right. There was a good amount of chat going on in the chat, but it was all, I think, handled.
Good.
The one thing I will add is, when I first started learning unit testing and then test-driven development, I remember lots of people saying, "Oh, trying to unit test a legacy thing is really, really hard." Now, after you know a little bit about how to do it, you find that starting in a green field where nothing exists is actually a little harder, because you have to think for a moment, what do I need to test that doesn't exist that I didn't need to go create? And I find if I get stuck, I may go scaffold out a class that has, like you had there in that other project, lots of things with throw not implemented.
Right.
Or default.
Yeah, for sure.
So the axiom there is, if you don't know what it should be, make a default that is bad and just fake it for a while until you figure out what it's supposed to be.
Right.
Just don't release it to production that way.
Yeah.
All right, Tyler, well, really appreciate you joining us and presenting this fantastic, you're giving us your fantastic knowledge with this great presentation.